Hello everyone. This video is on the Knewton Alta assignment for section 5.2 called End Behavior of Polynomial Functions. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, so I'm hoping the questions are similar enough so that watching me do a few here will help you in some way when you work on them on your own. Alright, so on your assignment page you should see the title, your mastery bar, the objectives. It looks like there are 2 objectives for this particular assignment. And then under the current objective should be a question related to that objective. And at the bottom of every question you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. This is for instructors only. But you will have a more instruction button. So if you're struggling with a topic, click on more instruction. You'll be given further reading or videos to watch and then some questions related to that instruction, and you can move through the assignment that way if you wish. Alright, so this first objective is identify power functions and polynomial functions. Right, so before I actually get into the question, I want to talk about what these are. What are power functions and polynomial functions as they are defined by the instruction in Knewton. Right, so first, the power functions look like the following. So any function that takes the following form or can take the following form. So f of x equals, right, so the input is x, equals a times x to the p. I'll use p, right, for power, where a and p are real numbers. And that's it. So examples, f of x or y equals, any constant, 3. Because that would be 3 times x to the 0 power. Alright, so just 3. Just any constant would be fine. Y equals, x to the first. Y equals, 1/3 times x to the -5th. Y equals the square root of 2 times x to the 1/3 power. And y equals -pi times x to the to the pi power. Right? It's just a real number times your variable to another real number power. Now, polynomial functions, the other kind of function you're going to be asked to identify. Polynomial functions are just a sum of power functions where all the powers, or all the exponents on the variable, are whole numbers. Right? So polynomial functions can take the following form. Right? Any expression, any function that can take the following form. So f of x equals, and we have some numbers with subscripts, right? So a sub n times x, right, the input variable, to the nth power, plus a sub n minus 1 times x to the n minus 1 power, and this keeps going. Now, a polynomial can have one term or many terms, right? All the way down to, say, a sub 1 times x to the 1 plus, and then a constant term, a sub 0, right? Where a sub 0, a sub 1, all the way up to a sub n, these are, real numbers that are not all 0. I'll just say real numbers. And n, basically all the powers, n minus 1 and so on, are whole numbers. Alright, so again, exponents are whole numbers. Powers are whole numbers. Now remember, the whole numbers are 0, 1, 2, 3, 4, just, no negative powers, no fraction powers, no decimal powers, right, other than whole number decimals. So, back here, just f of x equals 3, that would be a polynomial, right? The power on the variable is a whole number. Same thing for y equals x, that's x to the first. The power on the variable is a whole number. So these would be polynomials, these power functions. But then the rest of them, would not be polynomials. Right? So these two would be considered power functions that are also polynomial functions. These three, where the power on the variable isn't a whole number, negative 5 isn't a whole number, 1/3, pi, these are power functions that are not polynomial functions. Right. Okay. Yeah, so basically it's power functions that are added together, but the powers are whole numbers. Right, the powers have to be whole numbers in order for it to be considered a polynomial function. And we'll see examples of this here. Right, so in the first question, which of the following is a polynomial function? And select all correct answers, right? So multiple answers may apply. So f of x equals, negative 2 times x to the first plus 1. Technically, remember, any constant term you can think of as having times x to the 0. So you see the variables x to the 1, x to the 0. Basically, it's two power functions added together where the powers are whole numbers. So this is a polynomial function. Second one, f of x equals 2 times 5 to the x. Now, notice, right, in these polynomial functions, the variable is the base, and then you have a number exponent, not the other way around, right? Here, there's a number in the base. I don't want to click on that, but there's a number in the base, and the variable's in the exponent. That's not happening in a polynomial function. If this is the case, what they would call this an exponential function, where there's a numerical base and a variable in the power, in the exponent. But we'll talk a lot more about exponential functions in chapter 6 sections. So that's not a polynomial. There's negative 3x squared minus 4x to the first plus 5, x to the second, x to the first, x to the 0. All the powers on the variables in each of these terms is a whole number. Right? It's the sum of three power functions where all the powers are whole numbers. So this is a polynomial function. And then these last two have the same problem as the second one here, where instead it's not a, it's not x to the 12th. If it were 5 times x to the 12th, that would be a polynomial. But it's 12 to the x. That's totally different. The numerical base and variable power. So this is another one of those exponential functions. Same thing here. If this was 3 times x to the second power, then you would have a polynomial. But it's not that. It's 3 times 2 to the x power. So another exponential function. So the only two I've selected are the two polynomials. Now after you submit a question, an answer, it'll tell you if you're right or wrong. Sometimes it'll give you an extra chance. But then after your final chance, it'll give you an answer explanation. Please read through the answer explanations, because I want you to understand why you got something right or why you got something wrong, especially. So hopefully you'll learn from your mistakes for the future. All right, the next question. All right, still on the same objective, identifying power functions and polynomial functions. All right, so is the following a power function, a polynomial, both, or neither? So we have f of x equals 4x cubed plus 4x squared plus 5x to the first plus 3. Now it's not a power function, right? Because a power function is by definition a single term, right? Just one term. Real number times variable to a real number power. One term. A polynomial function is the sum of, a polynomial function can also be one term, right? Like I said here, these two power functions are also polynomials. They have whole number powers. But it can also have many terms, right? Polynomial, poly for many, many name, many term. But again, all the powers, all the exponents have to be whole numbers, though, to be considered polynomial. So that's what we have here, right? All four of these terms, 4x cubed, 4x squared, 5x, 3, are a number times a variable to a whole number power. There's no negative powers, no fraction powers, no decimal powers that aren't whole number decimals. So this is a polynomial function, but it's not a power function, right? If it was just 4x cubed without all the other terms, or just 4x squared without all the other terms, then it would also be a power function. But it's not that, right? So just a polynomial function here. Okay. All right, so now we're talking about determine end behavior. So this is what happens in the graph of a polynomial function. So you notice all these options here are polynomial functions, right? It's a bunch of power functions with powers that are whole numbers added together. So let's talk about what happens on the far right and far left of the graphs of polynomial functions. So talking on the same page with polynomial functions here, their end behavior. So this is what happens to f of x, what happens to the output what happens to f of x as x goes to infinity or as x goes to negative infinity, right, with these arrows. Now x going to infinity is the right end, would be the right end of the graph. X going to negative infinity would be the left end of the graph. And that's what you're asking when you're talking about end behavior. Now, because all these are whole number powers, if you're letting x get incredibly large, 100, 1,000, 1,000,000, 1,000,000,000, Googleplex, whatever, the highest powered term is going to be much larger than the rest of them. So n behavior is dictated by the lead term, the highest powered term. So if n, right, again, the power on the highest powered term, if n is odd, so again, say the highest powered term is 1 or 3 or 5, 7, 9, right, odd. Well, then you have the following cases, right? If n is odd and the lead coefficient is positive, so a sub n, right, the coefficient on that highest powered term, if that's positive, then the n behavior will be like this. So here's the x-axis, and the graph's going to do something like this. It's going to be going down to the left and up toward the right, to the on the right end. Down on the left end, up on the right end. Now the way we describe this is I would say as x approaches negative infinity, that'd be the going to the left forever. F of x is going to negative infinity, right? The output's going down. And as x goes to positive infinity, as you go to the right, the output's also going to positive infinity. Right? F of x is also going up. Right? This is how you describe the end behavior. Now, what happens for smaller values of x? I don't know. I might curve a bunch, but I can tell you that on the left end and right end, what the graph is going to be doing, right? Where the graph is going to be going. Now, if n is odd and the lead coefficient is negative, it just flips this. All right, then the end behavior will be, the left end, the graph is going to be going up. And on the right end, when x goes to infinity, the graph is going to be going down forever. It just flips that. So I would say as x goes to negative infinity, right, as we go to the left, the value of the function is going up. F of x is approaching positive infinity. And as x approaches positive infinity, as you go to the right end, the value of the function is going down, right? F of x is going to negative infinity, right? So this is how you would describe it with arrow notation. Now, those are the cases, those are what's happening to the graph of a function when n is odd, when the highest powered term has an odd power. Well, what if the highest powered term has an even power? So I'll keep that up. And now what if the highest powered term is even, right? Has an even power, 2, 4, 6, 8, and so on. Well, if n is even and that lead coefficient is positive, then the graph will be going up forever on both ends. So we could describe that all in one line here. Say as x goes to positive or negative infinity, you go to the right end or the left end, the value of the function f of x is going up. It's going to positive infinity. And if the lead coefficient is negative, just flip that over the x-axis. If the power of the highest powered term is even, they call that the degree of the polynomial. Right, the power on the highest powered term is called the degree. If the degree is even and the leading coefficient is negative, then on both ends, the left end and the right end, the graph will be going down forever. So again, we can say this all in one line. As x goes to positive or negative infinity, either end, the value of the function is going to negative infinity. Right? Graph's going down forever. All right, and we'll see this. I'll put up some graphs on that desmos.com website, the free online graphing calculator, with some of these examples. So here, sorry me, the graphs of which functions are increasing from the right to left and decreasing from left to right. So from right to left, going up. If you go from left to right, that's going down. So they're talking about this here. Right. That'd be like this here. If I go right to left, graph's going up. If I go left to right, the graph's going down, right, decreasing. So that's this here, this case. So I need an odd degree, or the highest power to be odd, and the lead coefficient to be negative. Right. So if you look, this first one, the highest powered term has a power of 3. It's odd degree, degree 3, and the lead coefficient is negative, right? So the graph of this will do what they're describing. And I'll show you. Let's go to this is desmos.com, right? Free online graphing calculator. I'll just put y equals, we have -4 times x cubed. And you see how if you go from left to right, it's decreasing, going down forever. If you go from right to left, increasing, right? Going up forever. And that's exactly what they described, increasing from right to left, decreasing from left to right. So again, odd degree, negative lead coefficient are what we're looking for. So this has an even degree. The highest power I'm seeing is 4. This is a degree 4 polynomial, even. Now it has a negative lead coefficient, meaning it's going to be going down on both sides forever, right? So we can see that here. Y equals, -8x to the 4th, plus 7. And you see how on both ends, to the far, if you go to the right, go to the left forever, you're going down on both ends. Right, go down, down. Right. So it's not that one. This has an odd degree. The highest powered term has a power of 3. It's degree 3, but it has a positive lead coefficient. So instead of going up to the left and down to the right, it's going to be going down to the left and up to the right. And again, I'll graph this one. Really, I just need the lead term. Right? See how this is going in 9x cubed, right? And then there was some other stuff. Down to the left, up to the right. The opposite of what they described. Here, f of x equals 14x to the 6th, and this is a degree 6 polynomial, even degree with a positive lead coefficient. So this is going to be going up on both ends. Right? The graph will be going up to the left and up to the right. Again, all I really need to show you the end behavior is the lead term. See, there's 14x to the 6th, and there was some other stuff, but see how it's going up to the left, up to the right. Here, degree 5. Negative lead coefficient. This is one I want. This polynomial will be going up to the left and down to the right, increasing from right to left, decreasing from left to right. And then finally, this one has highest power. The highest power I'm seeing here is 6, so it's degree 6, even, positive coefficient on that. So it's going to be going up on both ends. So the only two that I've selected are the only ones that are do what they described. And again, please read through the answer explanations. But I think end behavior should be pretty simple. You just need to find that highest powered term. All right, so again, if the end behavior is increasing to the left, what might be true about the function? Increasing to the left, going up to the left. So not this scenario, but up to the left. Increasing to the left. So this one, might have an odd degree and a negative lead coefficient, or this scenario is also increasing to the left, going up to the left. So it could have an even degree with a positive lead coefficient. Both of those could be happening here with this description. So even with a positive coefficient, or odd with a negative coefficient. Both will be equally valid. Is the following a power function, a polynomial, both or neither? All right, so now it's just a single term. You have a real number times the variable to another real number, 19 times x to the 10th. So this is a power function, and that power is a whole number, 10. So this is also a polynomial function. So it's both. It's both power and polynomial. Okay. All right, is the following a power function, a polynomial, both or neither? Anything with a special symbol in it is not going to be a polynomial. All right. Now you could write this to a power as well if you want. You could say it's negative x minus 4 to the half power, 1/2. I remember square root is the 1/2 power. But even so, that's not a power function because it's not just the power function is just the variable to a power, not the variable minus 4. All right. So it's not a power function, not a polynomial because that power is not a whole number. So it's neither. It doesn't satisfy either definition. All right, so that objective's done. And then back to end behavior. All right, so once again, as x approaches negative infinity, so that's going to the left end, for which of the following functions does f of x, does the output approach positive infinity? So those are those two scenarios we just talked about. As I go to the left, as x approaches negative infinity, f of x goes to positive infinity for this case, right, where again the odd degree negative lead coefficient, and for this one, right, x goes to negative infinity, f of x goes to positive infinity. That's even degree positive lead coefficient. So I'm looking for polynomials with an odd degree negative lead coefficient or even degree and a positive lead coefficient. This is odd degree positive coefficient. Nope. Even degree positive coefficient. Yes. Even degree, degree 8, positive coefficient. Yes. Odd degree negative lead coefficient. So yes. Even degree, degree 6, but negative lead coefficient. So the graph wouldn't be going to positive infinity on the left, it'd be going down on the left, and the output would be going to negative infinity. And finally, degree 7, odd with a negative lead coefficient. Also yes, this is the same as that third one I checked earlier. So all of these satisfy what they're talking about. As x approaches negative infinity, as I go to the far left of the graph, all these functions, all 4 that I selected, and you can put them in Desmos if you want to see, but their graphs, the output would be going up forever, approaching positive infinity to the left end. All right, I should have just one more of these with end behavior. All right, so this one's a little different because I need to multiply things out. And it says, which factor could be multiplied by the given function so that their product causes the graph of f to decrease as x approaches negative infinity? So this is a little trickier, but I'll write this one out. All right. So we're given f of x. Now we're given it in factored form, not the general form for a polynomial, 2x squared plus 5 times x minus 7. When I'm talking about end behavior, right, I just need to know the lead term. What would be the highest powered term? And if it's in factored form, if you want to find the highest powered term, just multiply the lead terms of each factor. All right, so that'd be 2x squared times x, the highest powered term from each factor. So that's 2x cubed. So right now, right, the end behavior right now would be like this. If I was graphing f, this has an odd degree, right, degree 3, positive lead coefficient, so it's going down to the left end, up to the right end. Now all I care about is the left end here, right? They're asking about the left end. All right, they're saying what factor could be multiplied by the given function so that their product causes the graph of f, the new graph, right, after you multiply, to decrease as x approaches negative infinity. So go down forever. So right now it's already going down forever. Now let's see what happens when I multiply by the factors they gave. All right, so for the first option, it's times -3. We're multiplying by times. Well, that'll make the lead term -6x cubed. And the end behavior would be this. You have an odd degree, negative lead coefficient. That's going up on the left. So no on that. All right, we want this. We want the graph to be decreasing, to be going down as x approaches negative infinity. So that's not good, not -3. The next factor they give us is 0.2x. Well, if I multiply this by again, this is the lead term that I'm multiplying by. Right? We're only focused on the lead term. 0.2x times this, the lead term. Maybe I'll write lead term here, make a little table. Multiply, that'd be 0.4 x to the fourth. So I have an even degree, positive lead coefficient. That'd be going up on both ends. It's not what we want. I don't want to go up to the left. I want to go down to the left. So not that either. The next one's 5x squared. So what if we multiply by 5x squared? Then the lead term would be 10x cubed. Or sorry, 10x to the fifth. Odd degree, positive lead coefficient. So down to the left, up to the right, absolutely. That's what we want. We want it to go down to the left. So this is a good option. 5x squared, I can multiply the function by that and it would still be going down to the left. All right, then after that, what about -1/2 times x plus 8? And again, all I care about is that lead term. So this is basically, I'm focusing on -1/2 times x. Right? And if I multiply the lead term of that by the lead term of this, I'd have -x to the fourth. It's got an even degree but a negative lead coefficient, so going down on both ends, and that's exactly what I want on the left end. So this is also a good choice. Multiplying by this would still give me a function that goes down to the left. Then the final option is 4 times 2x minus 7. Again, all I care about are the lead terms. 4 times 2x here, that'd be 8x, right? So I'm only focusing on really 8x. And if I multiply the lead term of our original polynomial by this, it'd be 16x to the fourth. Positive lead coefficient, even degree, that's going up on both ends. So no, that's not what I want. So the only two that really would have the same effect that I wish, if I take this polynomial here, multiply it by 5x squared, it's going to be going down to the left. As x approaches negative infinity, the value of f will decrease. And if I take f of x and multiply it by all this -1/2 times x plus 8 factor here, the resulting polynomial will be even degree negative lead coefficient, so it will also go down to the left as they want. Right? So just those two options, 5x squared and then this -1/2 times x plus 8. Great. All right, so that was a little trickier because you had to do really thinking. But again, the focus is on the lead terms, the highest powered terms. Right, of all the factors, because the highest powered terms, that highest powered term, that's going to determine your end behavior. That's going to dictate where the graph is going to be going as x approaches infinity or negative infinity, right? The far right end or the far left end. Wonderful. Okay, and that should be it for this preview version of this assignment. As I said at the top of the video, the questions I see here may not be the same questions you see when you work on the assignment yourself, but the objectives are the same. So I'm hoping that the questions are similar enough so that watching me do some help you out in some way when you work on the assignment on your own. And thank you very much for watching.